Hello everyone, I'm going to prove this very important formula. This is the formula of compound interest. Okay, when A is the accumulated amount, P is going to be the principal amount. Okay, so A is the accumulated amount, P is the principal amount, R is going to be the rate or the interest. Okay, and T is going to be the time. So first of all, we need to understand what is going to happen year after year so we can understand how to do a formula. So first year is going to be something like this. It's going to be the principal amount plus the principal amount times the rate. Okay, but second year is going to be a little bit different. It's going to be the principal amount plus the principal amount times R, because it's the amount that I already accumulated the first year, and then this amount that I already accumulated this first year is going to be multiplied again by R, okay, by the rate. And just for fun, we're going to do with the year number 3, okay? And yes, now I'm taking all the accumulated amount of the year number 2, so this is my amount, and then I'm going to multiply all that by R, okay, just for fun. Okay, so now if we understand year number 1, year number 2, and year number 3, now we need to understand how to do this with the structure of P times 1 plus R to the power of T. So basically, if we just do the factorization here, P plus P times R, we can take common factor P, and this is going to be P times 1 plus R. Well, this is actually satisfying the equation because T equals 1 is going to be P times 1 plus R. Okay, now what happens in the second year? The second year is going to be interesting. We're going to develop this. So P plus P times R is going to be exactly this expression, which is going to be P times 1 plus R. So we have P times 1 plus R plus P times 1 plus R times R. Okay? So we can take common factor here, but we are not going to take the common factor of P. Okay? We're going to take the common factor of 1 plus R. Okay? Be careful with that. If we take common factor 1 plus R, then I get here 1 plus R times P plus P times R. And we know that P plus P times R is equals to P times 1 plus R. So this is equals to P times 1 plus R, okay? And now we get 1 plus R times 1 plus R times P, which is just P times 1 plus R, and all this to the power of 2, which is also satisfying the equation because when the year is 2, T is equals 2. Okay? Great. Okay, now number 3. We have the number 3, the year number 3. So we need to be careful here because year number 2 is already P times 1 plus R to the power of 2. And all this thing is going to be actually P times 1 plus R to the power of 2. And here is just going to be P times 1 plus R to the power of 2 and times R. Oh, I forget here. Have to put here times R. Okay, there we go. So if I do the multiplication of this, it's really easy because this is just P times, look, P times 1R squared plus P times 1 plus R to the power of 2 times R. So here again, I'm not going to multiply this R, okay? I'm going to take common factor 1 plus R squared. When I'm taking 1 plus R squared common factor, I get 1 plus R to the power of 2 times, between parentheses, P plus P times R. So again, I have 1 plus R squared times, remember that P plus P times R is the first year, which is equivalent to P times 1 plus R. So I get 1 plus R squared times P times 1 plus R. And this is the same factor. So I can say 1 plus R squared times 1 plus R, which is 1 plus r to the power of 3, and of course multiplied by p. Okay, and I can do this with several years, several values, and I'm going to get exactly the same result always. So with these simple calculations, I prove in some way that the formula of the compound interest is p times 1 plus r to the power of t. So I hope this video has been helpful, and thank you. Bye bye.